In this video, we are going to look at what a convex mirror is, and it's a mirror whose reflecting surface curves outward. So because the image is smaller than the object, convex mirrors reflect from wider angles than flat mirrors. So essentially we're taking a large area and putting it onto a small surface. So we're going to take a look at a couple of rays here. There are three we're going to worry about. The first one is going to go parallel to our principal axis, and then it's going to reflect through the focal point. So what's that going to look like? So there is our first parallel line, and it is going to reflect off, and that is going to have to be in line with this focal point right here. So like that. Second line, it's going to pass through C and reflect back on itself. So there it is, and there we go. Now our third line is going to pass through F and reflect back parallel to the axis. Okay, so there it is. It's going to reflect back parallel to the axis, and it's going to be in line with the focal point. So what we're going to do is we're going to put all three of those lines together to see where an image will form. So there is our object, and there's our first line. Now what this one's going to do is it's going to reflect off and go with respect to the focal point. There we go. Second line, this one's heading straight through the center line, reflects back on itself. Now we've already got our two lines meeting and our image forming right there, but we can of course confirm with the third line that is going to reflect back parallel and go through. So there we go. We have our image right there. I'm going to draw over it. So if you want to come up with the image properties, our size is smaller. You can tell that this is clearly smaller than our original. It's upright. It is closer. In terms of closer, you know, if you had a ruler, you can measure this distance here. Maybe that's 5, and then you measure the distance from the mirror to the object. Maybe that's 10, and you say, okay, yeah, it's closer. And then lastly, it's a virtual image. It's appearing inside the mirror universe. Well, let's take a look at an example problem here. So we've got a few numbers we're going to have to worry about. We've got a focal length of -0.4. That's because it's inside. Our focal point is negative when we're dealing with a convex. We've got a person who's 1.7 meters tall, and they're standing 4.5 meters in front. So we're going to calculate the image distance using the mirror equation, which is right here. Now when it comes to the mirror equation, we are always going to be calculating DI. So we're going to a quick rearrangement. In fact, this is probably a better version of the formula to be using. So let's start plugging in some numbers here. So 1 over focal point. So we have 1 over -0.4 subtract 1 over our distance of our object, which is 4.5. So all of our numbers, the aforementioned numbers there. So now I would do on a calculator, instead of doing a fraction here, I would simply just type in 1 divided by -0.4 subtract 1 divided by 4.5. And if you do that, you should get -2.722, but we're not done. So what we got to do is we actually have to kind of flip these around. Maybe it's a little complicated mathematically, but the bottom line is you just go simply 1 divide by your answer. And when you do that, you should get -0.037. So what that means is, it means that the sign of the image distance is negative, so the image is behind the mirror and thus in the virtual universe. So another question we can do is we can calculate the height of the image here using our magnification equation right here. Now, since we're calculating for HI, it's probably more useful if we take this HO term and cross multiply it up to the top. So this is probably a more usable version of the formula. So now it's just a matter of plugging things in here. We've got the height of our object, which should be 1.7. We've got our distance of our object, which is 4.5. And in the previous question, we calculated the distance of the image. So let's take all those numbers. Now notice we've got a couple of negatives. This negative you can pretend is, say, that. And then that negative is coming from our last question. And so just be careful when you type that all into your calculator. Make sure you get 0.1386, double check. And all that means is the image height is positive, so the image is upright.